Happy to meet you in our next question. So this time we are going to solve an ISRO question. So ISRO, many people are aware of it, right? Indian Space Research Organization. From our childhood days, if someone is from ISRO, oh, scientist is a big guy, okay, they will be imagining like that. But there are also people like us, and if you could solve all these kinds of questions, and if you could solve this, if you could qualify this exam, ISRO exam, which is being conducted for engineers, you could very well be an ISRO scientist. So we'll see one question. So our concept, like we are solving the Lamis, we are solving this forces problem using Lamis theorem, right? So same concept we are going to apply it over here. So recent, just a year back we have got ISRO 2017, we have got a paper in which we had a question like the bar AC bar 10 meter long supports a load of 6000 Newton. As shown in the figure, the cable BC is horizontal. This is a cable, BC is a cable, is horizontal and 5 meter long. Forces in the cable and the bar are. So forces in the cable and the bar AC. So very simple, as we have seen in the earlier questions. I guess you can solve it by yourself. Just stop it. Okay, just apply Lamis theorem to point C. You will get the answer. I guess we have some options too, but we don't care about options, right? So once we get the answer, I'll write the options and then we'll proceed. First, applying Lamis theorem to point C. Before applying Lamis theorem, we need to know the angles. So we all know angle in a triangle is 180 degrees. So here we have got 90 degree over here. So 90 plus 130 is 120. Remaining angle is going to be 60 degrees. So very well, we can apply Lamis theorem to point C. So let's move ahead. Applying Lamis to C. So if I am going to apply Lamis to point C, we have 6000 Newton. Then we have the bar AC, force FAC. Then we have FBC. So these are the angles, and we know the rest of the angles too. So angle between FAC and 6000 is going to be 30 degrees because we have a 90 degree over here, and so already 60 is there. So we are going to get 30 degrees. So this is going to be 30, and this we already know it's going to be 60. Okay, so 60 plus 30, 90, remaining 270 degrees. Now very simple, just apply Lamis to concept and then we can know the answer. So what we are going to do right now is apply Lamis theorem. So first is 6000 divided by the angle opposite to this 6000 is FAC and FBC, angle between FAC and FBC, which is sine 60. Next, FAC is going to be angle is sine 270. Next, FBC angle is going to be FBC sine 30. Okay, now you can very easily solve this. Just take this equation out. FAC is going to be 6000 sine 60, sorry, 6000 sine 270 divided by sine 60 will fetch us AC. So 6928. FAC is going to be 6928 newtons. Next, very easy, calculate FBC same way. We get by using the calculator 6000 into sine 30. So sine 30 is 0.5 into 6000, 3000 divided by sine 60. 3000 into 2 divided by 1.732. 3464. 3464 newtons. So it's as simple as that. You are going to get an ISRO question very easily, right? So it's going to be very, very simple. So this is the same rule which applies for all subjects and all concepts. Once you know the concepts, it's very easy for you. Just you see the question, you see it in a way. Before the knowledge of Lami's theorem, you might be seeing, okay, how am I going to do this, and all those stuff will come into our mind. But right now, once we know Lami's theorem, we are confident once we see this question that we just look for 3 force joints. So we have a 3 force joints over here, and just apply it, get the answer. And normally we don't see 4 options, but for checking it out, this is option B. You can get ISRO 2017 question paper in Google. Just try googling it, and you'll have an answer key. There's official answer key. You can check it out. So we'll see in the next video.